gate. Let us move to the third gate. So this is the inverter or NOT gate. So it is one special type of logic gate. It is a special type of gate in this logic gates. Why I call it is a special type means, so except this NOT gate, every gate is going to have the more than one inputs. So except the NOT gate, every gate is going to have the more than one input. Only the gate which is having the one input is NOT gate. It has only one input. Obviously, for every gate we are going to have the one output only. Okay, for every gate we are going to have the one output. So here the inputs are, input is A input. I'm taking one input is A, and this is output. So what is the possible? How many combinations we can have here? A is a binary variable, so A can have the 0 or A can be 1. A can be 0 or A can be 1. So here NOT gate or inverter, we have seen already logical operations. This is by A complement or we call A bar or A complement or A inverter A naught. It means if A is 0, output is going to be 1. If A 1, output is going to be 0. It means for NOT gate, if you give the input as 0 and the output of the NOT gate is going to be 1, and if you give the input as 1, the output of NOT gate is going to be 0. So this is the thing about the NOT gate. It means if you say yes, this guy is going to be say no. If you say no, this will say yes. This reverse to you. So if the input is A, the output is what? A bar. So it is a symbol of the NOT gate. So here the thing is you should represent this bubble. At the end of the output, you should represent the bubble symbol. It will represent the complement. It will represent the complement. Without bubble, we don't use this bubble. Then if the input is A, the output is also called as A. That is called as a buffer. You know the meaning of buffer. You have seen in the analog electronics. Buffer means what? Whatever the input is be there, that will be applied at the output side. If the input voltage is 5 volts, output is also 5 volts. That is called buffer. So without this bubble, the output is going to be A. So you have to represent the bubble compulsory whenever you use the NOT gate. Now tell me, what about enable input and disable inputs? Does it exist for this NOT gate? Anybody could you answer me? Does enable input and disable input will exist for the NOT gate? Right? No. No, doesn't exist, right? Why? Because it's having only one input. It's having one input. So if you want enable input or disable input, you need the two inputs, right? So there is no enable input and disable inputs here. Let me write here. There is no enable input and disable input. Enable input and disable input. Coming to the switching diagram. Let's talk about the switching diagram, NOT gate. So we're having only one switch. There's only one input. Now tell me where I have to connect the switch here. You can observe this truth table and answer me anybody where we need to connect the switch A. Parallel to bulb, right? Any other answers? I got one answer. This parallel to bulb. He has given one answer. Any other? Only one person has answered. The answer he has given is parallel to bulb. You can observe the truth table here. So by observing that, you can tell me where you can connect the switch here. So here the switch will be connected in parallel to the both supply as well as the bulb here. We'll connect the switch to the in parallel to the both supply as well as the bulb here. Now you can observe if I give a value 0, if I give a value 0, what happened there? Switch is going to be what? Off. When a is 0, switch is going to be off. That is, it will be open. Switch will be open. So when switch is open, what happened? There is a connection between the input and output. Then LED is going to be operate. This bulb is going to be operate, right? So when that is the output is what? Logic 1. So you're getting output. The output means you're getting the output is logic 1. Okay. When A value is 1, when A value is 1, that means you're owning the switch A. You turn on the switch A and it is going to be what? Short circuit. Then A will be short circuit. When A is short circuit, what happened? Now this bulb is what? It is shorted. Bulb is shorted. When bulb is shorted, then what happened? The total current, whatever is there, is completely shorted through back to the supply. So in this way, the current will flow. Then what happened? There is no working of LED. That is output is going to be logic 0. So this is satisfying the NOT operation. The switching diagram satisfying the NOT operation. So that means the switching parallel to both supply and bulb. Both supply and bulb will construct the NOT operation. So it is about